So in this question, we're looking at the plane connecting 314, 271, and -1, -2, -3. So if we're going to create that equation of a plane, what we're going to need is a normal vector, which is going to involve the cross product. So what I'm going to do is I'm going to pin this at a starting point. I'll make the start -1, -2, -3, and I'll shoot it on out to the other two coordinates, and I'll call it, just for the sake of consistency, I'll say P here. I'll call this one Q. I'll call this R. So that makes this vector PQ. That's not a P. I'll make this vector PQ, and I'll make this vector PR. All right. So we're going to subtracting corresponding parts. I can also annotate it up here, but I can just kind of chuck it down off the side here so I can at least look at the diagram. Strategically deciding. All right, so PQ, I might move this in a minute, but 3 minus -1 is going to be 4. 1 minus -2 is going to be 3. 4 minus -3 is going to be 7. All right, and then PR, 2 minus -1, 3. 7 minus -2 is 9. And then 1 minus -3 is going to be 4. So I need the cross of those two vectors. That'll give me my normal vector. And whether or not you want to visualize it, plot it, and all that is up to you. I might take a quick look. GeoGebra is a good resource when it comes to that. But the cross of these two vectors, so I, J, K, 4, 3, 7, 3, 9, 4. So for the I, so for the I, I'm ignoring the I. So I'll highlight the thing that I'm ignoring, which seems to be kind of counterintuitive. But 3 times 4 is 12. 9 times 7 is 63. So 12 minus 63 is a -51. Yeah. So -51I. Then I'm looking for J. So minus is built in. So 16 minus 21 is -5. So plus 5J. And then for K, swing this on down the line. Oop, I just missed. So 36 minus 9, 27. So plus 27K. All right, so this is going to be my normal vector. So N, put it in quotes, is going to be -51, 5, 27. All right, so we're good there. We got our normal vector. All right, we know that the plane is going to be based off of this normal vector, but it's also going to have to pass through, well, all of the points, but I only need it to pass through one of the points. All right, so I've already designated this one as P, so that's what I'm going to do. I'm going to go with that one as the P. All right, so vector P -1, -2, -3. All right. So we're going to dot that against our normal vector. All right. So, you just go back to the model here. Just on the previous page, I got a little stray mark there now. Undo. And look at what we're doing here. We have the vector. P. I'm sorry, I meant Q, but it really doesn't matter. It's just that we're going to have n dotted against p and q. It's just a question of which is on the left and which is on the right. So the vector q is our xyz. All right, so that's all this stuff. We're dotting that against our normal vector, but we're also dotting our normal vector against the coordinate in the plane. All right, so it's all coming back to that. So let me just jot down what my vector q is. I'm using capital Q. Well, you know what, maybe just for the sake of sanity here, I should use something else. So I'll use a lowercase q to represent the variable vector xyz. Just so I don't confuse that too much with the q that I already used as one of the points. So I need n dot q. So these vectors, if I can get it to look nice enough, and then n dotted against p. All right. So on the left-hand side, that's easy enough, because if I'm dotting this n against xyz, it's really just going to slap a xyz correspondingly onto each of the components. The x onto the negative 51, the y onto the 5, and the z onto the 27. So I'll just rewrite that. I'll do it in black. Negative 51x plus 5y plus 27z. Now on the right hand side, same story, different chapter. So I'm putting this right yeah. But then I also need this Jimmy Jammy over here. So that's going to be the result of adding the corresponding products. So negative 51, I'm just going to kind of do it off on the fly here. Well, that is really just going to be 51, but I'll just show it anyway. Plus 5 times negative 2 plus 27 times negative 3. And so that'll give us a negative 40. Just doing a quick double check to make sure that I typed it in correctly. So far, so good. Yep, so negative 40. So that ends up being the dot on the right-hand side, which gives me what I'm looking for, and that would be the equation of the plane.